Welcome to the latest video on our channel. Today, I will take you to a deep place in the universe where mysteries remain unsolved, where astronomical phenomena exist that even scientists marvel at. One of the most fascinating phenomena is the Fermi Bubbles. But bubbles aren't exactly something we encounter every day, are they? So why are they called Fermi Bubbles? And why are they so important to science? Imagine you're standing at the center of the Milky Way, where a supermassive black hole could devour an entire star in an instant. And in this vast space, a strange event occurs. Two massive plasma bubbles emerge from the center, stretching across thousands of light years, emitting X-rays radiation that can only be observed from beyond space. These bubbles aren't just peculiar. They may hold the key to unlocking many mysteries of the universe that humanity has never understood. So why do the Fermi Bubbles attract the attention of scientists and space enthusiasts alike? We will explore the secrets surrounding them in this video. Perhaps you've heard about black holes, but have you ever considered that a supermassive black hole could shoot out enormous bubbles filled with energy and intense light? And the more important question is, what could these bubbles tell us about how the universe operates, about the formation of galaxies, and even about extraterrestrial life? Let's dive into the truth behind the Fermi Bubbles. A groundbreaking discovery in modern astronomy that could be the key to unlocking many of the answers we've been searching for. So what exactly are the Fermi Bubbles? Let's start with an easy-to-understand definition. The Fermi Bubbles are two massive plasma structures that stretch over thousands of light years and are located at the center of the Milky Way galaxy. These structures contain extremely hot plasma and emit strong X-ray and gamma-ray radiation. They are unlike anything we can observe in our solar system. Although called bubbles, they are actually regions filled with extremely hot and high-energy matter made up of ions and charged particles. What's strange is that these bubbles are not just simple patches of plasma. Each bubble can extend up to 25,000 light-years in length and reach a height of 50,000 light-years, occupying a third of the sky when viewed from Earth. They are so massive that if you looked at them from a distance, you would feel like they dominate the entire sky, like giant plasma columns shooting out from the center of the Milky Way. What's fascinating is that these bubbles are not a new discovery. They were first detected by astronomers in 2010, thanks to data from NASA's Chandra X-ray Observatory. This telescope is particularly powerful for observing X-rays and gamma rays, types of radiation that our naked eyes can't see. Both of the Fermi Bubbles emit energy in the form of X-rays and gamma rays with strong intensity. This makes them one of the most important subjects of study in cosmology. The plasma within the bubbles has temperatures reaching millions of degrees Celsius, much hotter than anything we could experience on Earth. One of the most remarkable features of the Fermi Bubbles is their emission of powerful X-rays, which allows scientists to observe and study these structures from afar. While we cannot see X-rays, with the naked eye, special telescopes are designed to break through the Earth's atmosphere, enabling us to explore these distant cosmic phenomena. This is a major achievement in space research, as X-rays provide valuable information about hot, high-energy objects such as stars, black holes, and other celestial bodies. So why are the Fermi Bubbles important to scientific research? In fact, they're not just simple bubbles in space. They are part of a crucial process that helps scientists understand more about the center of the Milky Way and how powerful forces in the universe operate. In reality, the Fermi Bubbles could be evidence of energy being emitted from a supermassive black hole at the center of our galaxy, offering us a chance to better understand how this black hole influences the surrounding matter. In the next part, we will explore more about the theories surrounding the origin of the Fermi Bubbles, questions that astronomers are still working hard to answer. Let's continue the exploration. One of the most popular theories about the origin of the Fermi Bubbles is that they could be the result of an extremely powerful energy eruption from the supermassive black hole at the center of the Milky Way, known as Sagittarius A. Esker. A as This black hole has a mass millions of times that of the Sun and is believed to have the ability to consume all matter and energy within its proximity. This supermassive black hole is not just a point of light in the universe. It's a massive machine capable of generating enormous amounts of energy. When matter, whether gas, cosmic dust, or even stars, is drawn into the black hole, it is accelerated to extreme speeds, releasing a tremendous amount of energy outwards. This could explain the formation of the Fermi Bubbles, where hot plasma and energetic particles are pushed out from the center of the Milky Way, creating the giant structures we observe. One common model suggests that when material is drawn into the black hole, it can trigger massive energy explosions, sending shockwaves and intense radiation outward. These eruptions could push gas and plasma out, and especially they might form hot plasma bubbles, like the Fermi Bubbles we observe. In fact, these bubbles might be signs of past powerful eruptions at the center of the Milky Way, where immense energy interactions took place. These energy surges could provide us with valuable insights into how the black hole breathes and how it affects the surrounding environment. In addition to the black hole hypothesis, there is another theory involving stellar collisions or explosions from objects in space. When stars in the central region of the Milky Way collide with each other or with surrounding matter, the released energy could create strong shockwaves that push plasma and matter outward, forming bubbles similar to the ones we observe. Another theory posits that the Fermi Bubbles could be the result of explosions from supercharged objects, such as supernovae or other extreme cosmic events. The shockwaves and energy dispersion from these events could generate an effect similar to the creation of giant bubbles filled with plasma and charged particles. While these hypotheses are reasonable and quite convincing, why haven't we fully understood the Fermi Bubbles yet? That's because we're dealing with one of the most perplexing cosmic mysteries. These bubbles are incredibly distant and exist in an area of space that we can't directly access. The Fermi Bubbles are located in a very special region of the Milky Way near the supermassive black hole, where intense forces and cosmic objects are interacting in complex ways. Moreover, they emit energy in X-ray and gamma-ray frequencies, which requires us to use very special equipment to observe them, and sometimes we still lack the technology to explore all of their characteristics. This presents not only a challenge for scientists, but also an opportunity for us to continue developing technology and expanding our research on previously unknown cosmic phenomena. Despite the various theories about the origin of the Fermi Bubbles, they remain a major enigma for the scientific community. Therefore, continuing to study and explore these bubbles could help us unlock cosmic mysteries, provide valuable information about the development and structure of galaxies, the interactions between powerful cosmic forces, and perhaps even change the way we understand black holes and other cosmic phenomena. Let's continue to follow and explore further in the next part, where we will delve into the significance of the Fermi Bubbles for the development of science and the mysteries they may help us uncover. One of the key reasons the Fermi Bubbles are so important to science is that they provide valuable insights into how powerful energy sources in the universe affect their surrounding environments. These bubbles might be signs of an extremely powerful energy release from the supermassive black hole at the center of the Milky Way galaxy. To visualize this, when matter is pulled into a black hole, it doesn't simply disappear. Instead, its energy can be emitted in the form of X-rays, gamma rays, and intense shock waves. These energy bursts can be pushed outward into space, altering the structure of the regions around the black hole and potentially forming colossal structures like the Fermi Bubbles. This helps us understand more about the powerful forces at work in the universe, especially in areas near supermassive black holes. Moreover, the Fermi Bubbles also allow us to study the distribution of energy in space. By observing these structures, scientists can measure and analyze how energy is spread and released throughout the cosmos, shedding light on previously unexplainable phenomena. The Fermi Bubbles also serve as a key to understanding the evolution of the Milky Way. The center of our galaxy is a place of intense activity, such as eruptions from the supermassive black hole star explosions and interactions between stars and matter in space. These events not only generate energy but also contribute to the development of the galaxy. Through the study of the Fermi Bubbles, we can gain a deeper understanding of the processes behind the formation and growth of galaxies, as well as the role black holes play in the evolution of the universe. These bubbles might be signs of how the center of the Milky Way develops, changes, and impacts the surrounding regions. This is not only important for studying the Milky Way, but also for understanding other galaxies in the universe. By studying phenomena like the Fermi Bubbles, scientists can compare and analyze other galaxies, revealing common laws of formation and development in the cosmos. The plasma and X-rays emitted by the Fermi Bubbles play a significant role in cosmic research. Plasma is a state of matter in which charged particles such as ions are free to move. It exists at extremely high temperatures, like the plasma found in the Fermi Bubbles. This plasma can be used to study the properties of energy in the universe, helping astronomers understand better the extremely hot and high-energy environments found in outer space. In addition to plasma, X-rays are a crucial factor for studying the cosmos. X-rays can provide information about extremely hot objects like stars, black holes, and extreme physical processes in space. Since X-rays cannot pass through Earth's atmosphere, we must use space telescopes like Chandra X-ray Observatory to detect and study them. The X-ray emission from the Fermi Bubbles helps scientists analyze and better understand cosmic phenomena, from energy releases to the interaction of matter in the universe. One of the most important reasons the Fermi Bubbles are so fascinating to scientists is that they raise many big questions about the universe. These questions don't just relate to black holes and energy emissions, but also to how forces influence the formation and development of galaxies. One major question the Fermi Bubbles pose is, why are there such massive structures near the centers of galaxies? Many hypotheses have been proposed, but no definitive answer has been reached. Could the Fermi Bubbles be evidence of a larger cosmic mechanism that we have yet to comprehend? Are we witnessing signs of a cosmic process never before discovered? Additionally, the Fermi Bubbles also make us question the possibility of extraterrestrial life. Could such extreme phenomena create environments with unique conditions for life, or even influence the formation of life in other parts of the universe? In conclusion, the Fermi Bubbles are not only a mysterious phenomenon in the universe, but they also offer a valuable window into understanding the powerful and complex processes occurring at the center of the Milky Way. Research on the Fermi Bubbles will help us unlock many cosmic secrets, from the energy emissions of black holes to the evolution of galaxies. In the next part, we will explore the unresolved questions about the Fermi Bubbles and why they remain one of the greatest mysteries for scientists today. Despite the many studies and hypotheses about the Fermi Bubbles, they remain one of the greatest mysteries in astronomy. The Fermi Bubbles are not just a simple phenomenon in space. They are a key that unlocks many unanswered questions about the universe we live in. One of the first major questions is, why did the Fermi Bubbles form near the center of the Milky Way? This is an important question because the center of the Milky Way houses a supermassive black hole, Sagittarius A. This question relates to how supermassive black holes affect the surrounding matter and influence the development of galaxies. Could the formation of the Fermi Bubbles help us better understand this process? The second question is, could the Fermi Bubbles be signs of a larger phenomenon that we have not yet recognized? We know that the universe is continuously expanding, and there's still much we haven't explored. The Fermi Bubbles might just be a part of a much larger process that we haven't fully understood. Although the Fermi Bubbles have attracted significant attention in the scientific community, there is still much we don't know about them. One of the reasons scientists find it difficult to study these bubbles is because they are so distant and located in a cosmic environment that we cannot directly access. Even with powerful telescopes, they only offer us a small glimpse of the larger picture of what is happening at the center of the Milky Way. Furthermore, the Fermi Bubbles emit energy in X-ray and gamma-ray frequencies, which requires specialized tools for analysis. It's not always possible to fully explain how and why these bubbles form simply through observations from space telescopes. As a result, scientists continue to face significant challenges in understanding the mechanisms behind this phenomenon. Another question posed by the Fermi bubbles is, could they be a sign of extraterrestrial life? While this might be a bold hypothesis, if such powerful energy phenomena occur near star systems or planets, could they create environments conducive to life beyond Earth? The Fermi bubbles might not just be a physical phenomenon, but also a clue to understanding extraterrestrial life. While we have some theories and hypotheses, the Fermi bubbles still remain a challenge for scientists. But that's precisely why studying them is such an important step in expanding our understanding of the universe. This research not only matters for unraveling the formation and evolution of the Milky Way, but it also opens the door for us to learn more about supermassive black holes and other extreme phenomena in the universe. The Fermi bubbles could be an important stepping stone in helping us explore greater mysteries about the formation and development of galaxies, how energy and matter in the universe interact, and how these interactions change over billions of years. These studies will expand our understanding of the universe not only from a physical standpoint, but also from a biological perspective. As such, phenomena could impact conditions for life beyond Earth. The final question the Fermi bubbles raise is, are we on the brink of a major discovery in the universe? Every time a mystery like this is uncovered, it brings humanity closer to unraveling the marvels of the cosmos. The Fermi bubbles could be an important step in understanding how powerful forces in the universe interact and affect galaxies, planets, and perhaps even life beyond Earth. With advancements in technology and research, we can hope that these questions will be gradually answered in the future. This will not only enrich our understanding of the universe, but also could lead to new applications in science technology and even the search for extraterrestrial life. So the Fermi bubbles are not just an intriguing mystery in the universe, but they are also one of the important keys that help us expand our understanding of the world around us. They don't just help us answer major questions about the cosmos, but they also ignite humanity's curiosity to explore new frontiers in science. Let's look forward to further discoveries as we continue to study and learn more about the Fermi bubbles and this marvelous universe. When we look at the Fermi bubbles, they are not just vast cosmic structures, but also a testament to humanity's unrelenting curiosity in exploring the unknown. The universe, with all its mystery and complexity, constantly challenges us to seek answers to the big questions. Discoveries like the Fermi bubbles help us expand the boundaries of our understanding and create new opportunities for us to not only comprehend space, but also to understand ourselves. The Fermi bubbles are a clear example of how astronomical phenomena can influence our way of thinking. Even though we stand on a tiny planet in the vast universe, this exploration connects us with the world around us and even with distant, mysterious places that our eyes cannot see. The Fermi bubbles are not just a cosmic phenomenon. They are part of the larger story we are writing about our understanding of the universe. One important lesson the Fermi bubbles teach us is the value of never stopping our search, never ceasing to explore. Although the questions posed by the Fermi bubbles remain unanswered, the curiosity and efforts of scientists will continue to unravel deeper mysteries of the cosmos. This applies to our own lives as well. We must always seek answers, learn, and accept that each new discovery will lead to even more questions. So to you, those who love science and the exploration of the universe, let's continue to follow and explore fascinating phenomena like the Fermi bubbles. Will we discover the full answers to their origin in the future? And will we unlock even more cosmic secrets that were once unknown to us? If you found this video interesting and want to dive deeper into more wondrous astronomical phenomena, don't forget to hit the subscribe button and turn on notifications so you won't miss our upcoming videos. Feel free to share your thoughts on the Fermi bubbles and any cosmic discoveries you want to learn more about in the comments below. We look forward to receiving your questions and ideas as we continue this journey of exploration. Thank you for watching, and we hope these cosmic mysteries continue to inspire you to keep learning and exploring.